Good evening, welcome to Sakalavidya Educational Channel. So now today we discuss problems on homogeneous differential equations, part 10. So under this part 10 we are going to discuss the problems on homogeneous differential equations. In the last session we have completed the concept of homogeneous function and also what is the concept of homogeneous differential equations and how to solve homogeneous differential equations, that we have studied yesterday class. Today we will discuss the problems, we will concentrate on the problems. So very important regarding to the all sort of examinations, engineering mathematics examination, even B.SC examination, sometimes it may be M.SC examination also, PGT, TGT, some other entrance, different entrance examinations also. So now let us start with the first question. So all of you note down the first question now. First question, question number 1, solve x square plus y square dx is equal to 2xy dy. So how do we recognize that the given equation is homogeneous differential equation? Very simple. X square plus y square is a function of x comma y and xy is also function of x comma y. So but it should be put in the form of dy by dx form. So solution, the given differential equation can be written like this: dy by dx is equal to x square plus y square divided by 2xy. So write down given differential equation, given differential equation, given differential equation, given differential equation is dy by dx, dy by dx equals to x square plus y square upon 2xy or divided by 2xy. So we need to verify that whether x square plus y square divided by 2xy is a homogeneous function or not. So here x square plus y square means, for example, take x square common, you get 1 plus y square upon x square divided by, in the denominator also, now you can write 2xy here. Now x square by x is equal to, what do you write now here, or divide by this also x square on divide by x square. So this we can write now here x times, otherwise actually you can take x square common, okay, x square common. Here also this we can write x square of 2 of y by x, write down x square gets cancelled. So now it is appears to be function of y by x, f of y by x, and actually here x power 0 here we can write x square by x square means x power 0, degree is 0 and function in x comma y. So this is said to be a homogeneous function itself only. So that means x square plus y square by 2xy, here see x square second degree plus y square second degree, x into y is also second degree. So that means it is a actually homogeneous function in x comma y. So that's why this can be put in the form of, it is in the form of actually, now it is in the form of dy by dx is equal to f of y by x. This is actually we will consider as a type 1 problem. Dy by dx is equal to f of y by x. Now in the place of y we write vx. So let us start. Now let us say or put y is equal to vx. Differentiate both sides with respect to x. So dy by dx equals to, say this is equation 1, say equation 2, this is dy by dx is equal to v plus x differentiation 1 x into dv by dx. So now let us substitute in the given equation let us substitute in the given equation, otherwise, so this is set 3, substitute the 2 and 3 in equation 1. See, let us see what do we get now. Here we will get like this now. So, substituting 2 and 3, that means the values of 2 and 3 in equation 1, we get, see, in the place of dy by dx we can write v plus x dv by dx is equal to x square plus, in the place of y write down vx, y square means vx whole square, that is v square x square divided by 2x into vx. 2x into vx means what do we get now? 2vx square. 2vx square. So, then what shall we do now here? See, now this we can write here x square common from numerator, 1 plus v square divided by 2vx square. So, x square gets cancelled. We have 1 plus v square upon 2v or divided by 2v. So, now here let us transpose v to the right hand side. So, then what do we get now? By transposing v to the right hand side, we get x dv by dx equals to 1 plus v square divided by 2v and minus v. So, let us simplify right hand side. So, here 2v is the LCM. So, now this is 2v is the LCM, 2v divided by 2v 1. So, 1 into 1 plus v square, 1 plus v square, and 2v into negative v. So, negative 2v square. So, now this can be simplified, minus 2v square plus v square minus v square you will be getting. So, this is equal to, we can write 1 minus v square by 2v. Now, easily it can be written as variable separable form. How do you write variable separable form? So, bring the function of v to the left hand side and with dv, and x by dx to the right hand side. So, that what do we write now? So, this can be written as, see, now 2v by 1 minus v square dv, this. So, that means dv is the differential of v is equal to x by dx, we can write dx by x. Now, integrating on both sides, So, by converting variable separable, now we need to integrate on both sides or integrating on both sides. Then what do we get? So, after integration we get integral of 2v divided by 1 minus v square dv is equal to integral of dx by x. So, just observe the left hand side. 2v is the part of the derivative of 1 minus v square. What is the derivative of 1 minus v square? Minus 2v with respect to v itself only. But here we have 2v, that can be adjusted, no problem. But it seems to be rather f dash x by f of x formula. So, write down here integral f dash x by f of x dx equals to, we have log mod f of x. I hope it is very clear, plus constant of integration. So, now this can be written as, so this we can write minus of integral of minus 2v by 1 minus v square dv is equal to integral of dx by x. See, according to this formula, integral of minus 2b by 1 minus v square, you can write log mod 1 minus v square, but minus is there, minus log mod 1 minus v square. So integral of 1 by x dx is log mod x plus log mod c, write down, because all functions are in terms of log, so that the constant can be expressed in terms of log also, it can be written log also, log c. So now this we can write, bring this minus log 1 minus v square this side, log c this side also. This we can write log of mod x plus log of mod 1 minus v square is equal to log mod c. See, log a plus log b formula, log ab we can write. So this can be written as log of mod x times 1 minus v square equal to log c. So both sides if you compare, so this must be equal to x into 1 minus v square must be equal to c. So that we get x times 1 minus v square is equal to c. But actually you must remember one thing, but instead of v we need to substitute y by x, because actually here since y is equal to vx, so v becomes y upon x, function of x only. So let us substitute and make it simplify, so that we will get the general solution of the given differential equation. So now substituting v for y by x, this we can write x times 1 minus v square. V square means y by x whole square, y square by x square is equal to c. So now x into, here x square is the LCM, x square into 1 x square, so minus y square is equal to c. So x by x square means x cancel, here we have, by cross multiplication we get x square minus y square is equal to c into x cx. So this is the required general solution of the given differential equation. I hope you might have followed this question. So x square minus y square is equal to cx, this is the required general solution. So let me explain once again. You see, very simple. See, this is the given differential equation, this is the given differential equation. So now the given differential equation we need to write this form, dy by dx is equal to f of y by x or g of x by y, any form you can write it. This is model number 1. So dy by dx is equal to x square plus y square by 2xy. X square plus y square by 2xy is a homogeneous function of degree 0 in x comma y. So that's why this is a homogeneous differential equation of first order, first degree itself only. So now put y is equal to vx, differentiating on both sides, dy by dx is equal to v plus x into dv by dx. Substituting this 2 and 3 values in equation 1, we get in the place of dy by dx, so v plus x dv by dx is equal to x square plus in the place of y vx, so that is vx whole square means v square x square by 2x into vx, that is 2v x square. From the numerator take x square common, x square into 1 plus v square by 2v x square, x square and x square gets cancelled, we have 1 plus v square by 2v. So next step we have here, transpose this v to this right hand side. So x dv by dx is equal to 1 plus v square by 2v minus v. LCM is 2v. So 1 plus v square, 2v into minus v minus 2v square. So minus 2v square plus v square is minus v square, but 1 is there, 1 minus v square by 2v. So now this can be put in this in variable separable form. So take the function of v, that is 1 minus v square by 2v, to the left hand side, that becomes reciprocal 2v by 1 minus v square dv, and x by dx also becomes reciprocal if you transpose to the right hand side. So this can be written dx by x. So integrating on both sides. So integral of 2v by 1 minus v square dv, integral of dx by x. 2v is the part of the derivative of 1 minus v square, but really the 1 minus v square derivative is minus 2v. So we need to make such that minus 2v. So minus of integral minus 2v by 1 minus v square dv, integral of dx by x. Now this is in the form of integral f dash x by f of x dx log mod f of x plus c. This is minus log mod 1 minus v square is equal to integral of 1 by x dx is log mod x, because all the terms are in logarithms. So constant also we can write in terms of log only, log mod c. So take negative log mod 1 minus v square this side, log c that side, but whether it is negative or positive it makes no difference. So let us write log mod c itself only. So log mod x plus log mod 1 minus v square is equal to log mod c. Log a plus log b is equal to log of ab. So log mod x into 1 minus v square is equal to log mod c. So comparing on both sides we get x into 1 minus v square is equal to c. Let us substitute as y is equal to vx, v obviously becomes y upon x. So in the place of v write down y upon x. So v square means y square by x square. So x into 1 minus v square means 1 minus y square by x square is equal to c. Now take LCM x square. So x square minus y square by x square, but x by x square means here x we get by cross multiplication, x minus y square is equal to cx. So this is the required general solution, right. So let us move to the next question, second question. So second question, write down all of you. Solve 1 plus e power x by y times dx plus e power x by y times 1 minus x upon y dy equal to 0. So by observation itself only it is a homogeneous differential equation, but it looks like it is not in the form of dy by dx is equal to, it cannot be put in the form of dy by dx is equal to f of y by x, but it can be written as dx by dy form. This is second model, that also we can call it as format 2 or model number 2 also we can call, type 2 also. So now first of all we need to write dx by dy form. So we need to actually transpose the terms to the right hand side and we need to put dx by dy form. So then we need to put x is equal to vy, and so that we need to convert into the variable separable form. After that integrating we get the required solution. This is the process to be followed. Solution. So given differential equation, given differential equation is 1 plus e power x by y of dx plus e power x by y into 1 minus x by y dy is equal to 0. So first step here actually transpose the second term to the right hand side. So 1 plus e power x by y dx is equal to minus of e power x by y into 1 minus x by y dy. So as it is in the form of x by y, bring dy this side, this term this side. So now we can write dx by dy is equal to, so take minus inside of this bracket. So e power x upon y or x by y into x by y minus into 1 minus 1 minus into minus plus x by y minus 1 divided by this 1 plus e power x by y. It is absolutely, see my dear students, in the form of dx by dy is equal to g of x by y form. So that's why let us substitute x is equal to vy. So then we need to integrate it now. So let us say this is equation 1 now. Equation 1, right? Equation 1. Okay. Now put x is equal to vy. Differentiate both sides with respect to y, not with respect to x. So dx by dy is equal to v plus y derivative with respect to y is 1, v into 1 plus y into derivative of y with respect to, sorry, derivative of v with respect to y, that is dv by dy. So this we can write v plus y dv by dy. Say this is equation 2, say this is equation 3. Substituting 2 and 3 in equation 1 now. So let us substitute. This is also very important problem. So my dear students, please concentrate on this problem, right? So let us try to solve this question now. Okay. So now what shall we do now here? Substitute the values of 2 and 3 in equation 1. So substituting 2 and 3 in equation 2, sorry, in equation 1. What do we get? In the place of dx by dy, so we write v plus y dv by dy, okay, is equal to, so now in the place of x vy write down, vy means y gets cancelled, e to the power of v. Here x is vx, sorry, vy, y cancel, v minus 1 divided by 1 plus e power, x means vx, vy, y cancel, e to the power of v. Understood now? Understood? Yes or no? You need to chart. Yes or no? Yes, ESET, it is useful for ESET also, Mr. Appal Naidu. It will be very useful. Right. So now actually let us do one thing, transpose v to the right hand side. Then what do we get now? Let us see. So y dv by dy is equal to e power v into v minus 1 divided by 1 plus e to the power of v minus v. So then what shall we do? Very simple. LCM, let us take the LCM, that is 1 plus e power v. So now 1 plus e power v cancel. We have, open the bracket here, v into e power v minus e power v minus v into 1 minus v minus v into e power v minus v e power v. It's very interesting here, minus v into e power v plus v into e power v gets cancelled. So minus e power v minus v, take minus common, we have e power v plus v by 1 plus e power v. Okay. So now let us actually convert into the variable separable from. So here we can write, now you bring actually here minus e power v plus v by 1 plus v this side and y by dy to the right hand side. So by transposing, what do we get now here? So this can be written as, so 1 plus e power v, sorry. So v plus e power v dv is equal to, already negative we have, so minus dy by y. Clear? So now integrating on both sides. So on integrating, what do you get now? Let us see. On integrating on both sides, integrating on both sides, integrating on both sides, integrating on both sides. See, integrating on both sides, what do we get now here? Here we get integral of 1 plus e power v plus e power v dv. So minus common, integral of dy by y or 1 by y dy, whatever you can write it, no problem. See my dear students, 1 plus e power v is the derivative of v plus e power v. Because v derivative is 1, e power v derivative is e power v. That means f dash x by f of x. So here integral f dash x by f of x dx is equal to log mod f of x plus c. It's very important formula. Already in the previous problem also we have discussed. So now as 1 plus v is the derivative of v plus e power v, now this can be written as log mod v plus e power v. So minus log mod y, this is plus log c write down, log mod c write down. So bring minus log y to the left hand side, then what do we get? So log mod v plus e power v plus log y, log mod y equal to log mod c. Let us see what do we write. So in the left hand side, yes, you are correct. As this is in the form of, this one, log a plus log b form, log of ab. So that means you can write now this log of v plus e power v into y is equal to log mod c. Comparing on both sides, and comparing on both sides, you see v plus e power v into y is equal to c, you will get it. So therefore v plus e power v into y is equal to c, but we need to substitute the value of y. So here since so here x is equal to vy. So what does v stand for? Yes, v stand for x upon y or x divided by y. So let us substitute here. So let us substitute. What do we get? So what do we get here? So x upon y plus e power x upon y into y equal to c. Just open the bracket. Y into x by y gets cancelled. We have x plus y into e power xy, x by y is equal to constant. So this is the required differential equation. So this is the required differential equation. This is the required, general solution. General solution. I hope you might have followed this question now, right? X plus y into e power x by y is equal to c. Okay, let me explain this question once again step by step from the first question onwards. Now see, not first question, this is second question. We have been discussing second question. So this is very important question, right? Solve 1 plus e power x by y dx plus e power x by y into 1 minus x by y dy. So just by observation itself only we can say that the dx by dy can be written as a function of x by y itself only. So now the given differential equation first we need to write. So transpose e power x by y in 1 minus into 1 minus xy dy to the right hand side. That becomes 1 plus e power x by y dx is equal to minus e power x by y 1 minus x by y dy. So bring dy this side and 1 plus e power xy to the this side. Then we get dx by dy is equal to, here minus into 1 minus x by y, we can write x by y minus 1. So e power x by y into x by y minus 1 by this value 1 plus e power x by y, say equation 1. Now it is in the form of dx by dy is equal to g of x by y. So now say x is equal to, x is equal to vy. So differentiating both sides with respect to y, dx by dy is equal to, this UV method product rule, v into y derivative with respect to y is 1 plus y into derivative of v with respect to y, dv by dy. So we can write v into 1 v plus y dv by dy is equation 3. This equation 2 and equation 1 equation 3. Let us substitute 2, 3 in equation 1. So in the place of dx by dy, so v plus y dv by dy is equal to, next what do we write now here? In the place of this x vy, y cancel e power v. In the place of x vy, y cancel v minus 1 divided by 1 plus e power vy by y gets cancelled e power v. So now transpose this v to the right hand side. So y dv by dy is equal to e power v into v minus 1 divided by 1 plus e power v minus v. LCM, take the LCM, 1 plus e power v. So e power v into v, e power v into minus 1 minus e power v, and again minus this we need to multiply like this, minus v into plus 1 minus v into plus e power v minus v e power v, both minus v into e power v plus v into e power v gets cancelled. We have minus e power v minus v by 1 plus e power v, take minus common. So we have minus of e power v plus v by 1 plus e power v. This is function of v and dv dy are there only. So we can convert into the variable separable form. So bring e power v plus v by 1 plus v to the right hand side along with this dv. So this v becomes reciprocal this side. So 1 plus e power v by v plus e power v dv. So this y by dy becomes dy by y, already negative is there, so minus. Next, integrating on both sides. Integrating on both sides, what do we get? Integral of 1 plus e power v by v plus e power v dv is equal to minus integral of dy by y. As 1 plus e power v is the derivative of v plus e power v, that is log of v plus e power v is equal to minus integral of this one is actually log mod y and log mod c write down. Bring log y this side, then it becomes log mod v plus e power v plus log mod y is equal to log mod c. This log a plus log b, log of ab, so log mod v plus e power v into y is equal to log c. By comparing on both sides, what do we get? V plus e power v into y is equal to c. We have x is equal to vy. What is the value of v? That is x upon y. Let us substitute v for x by y plus e power x by y into y is equal to c. Open the bracket. X by y into y. Y gets cancelled, x plus e power x by y into y. That is y into e power x by y is equal to c. This is the required solution. Okay, I hope you might have followed this one now. Okay, let us proceed for next question, question number 3. Question number 3. Question number 3. Solve dy by dx is equal to y cube plus 3x square y divided by x cube plus 3xy square. See, y cube plus 3x square y divided by x cube plus 3xy square. Let us try to figure it out whether it is a homogeneous function of degree 0 or not. Here y cube, here x degree 2, y degree 1, 3, degree same, x cube 3, 1 plus 2, 3. So, by taking x square common and also x cube common out, so here also take x cube common out, here also x cube taken common out. So, that can be written dy by dx is equal to function of y by x. So, let us say y is equal to vx, then substitute dy by dx value and actually in the place of y vx write down. After prior simplification, it will be converted to the variable separable form, so that after integrating, so again by substituting the value of v, we get the general solution. So, this is the general process as to be followed. This comes under type 1 problem. Okay, let us solve it this one now. Solution. So, this is the given one is actually homogeneous differential equation, right? So, directly let us write it. Let y is equal to vx. Okay. Differentiate both sides with respect to x, dy by dx v plus x into dv by dx. Let us substitute these two values in given equation. So, now we have dy by dx is equal to y cube, y means vx. So, vx whole cube is v cube x cube plus 3x square into vx, that is 3x cube v divided by x cube only plus 3x into v square x square. So, that is 3v square x cube. So, now what shall we do now? Let us take out x cube from numerator, so that we get v cube plus 3v. So, divided by, take x cube common, we have 1 plus 3v square, 1 plus 3v square. And also dy by dx is equal to, you can write v plus x dv by dx. This also very important step. Dy by dx means v plus x dv by dx, and in the place of y, vx actually has been substituted and get simplified. So, x cube will get cancelled. So, we have v cube plus 3v divided by 1 plus 3v square. Now, transpose v this side now. So, then what do we get? Let us see. So, then we get here x dv by dx is equal to v cube plus 3v, so divided by 1 plus 3v square and minus v. Now, what shall we do now? Yes, you have the idea. So, this we can write 1 plus 3v square is the LCM. So, 1 plus 3v square, 1 plus 3v square gets cancelled. We have 1 into this one v cube plus 3v, and this we need to multiply, minus v into 1 plus 3v square, that is minus v. So, minus 3v cube we will get it. So, now we can simplify this one as v cube minus 3v cube minus 2v cube plus 3v minus v, that is plus 2v, divided by 1 plus 3v square. Now, take actually here minus 2v common, then what do we get? So, if you take minus 2v common, you get minus 2v common, you get v square minus 1 divided by 1 plus 3v square, you can write 1 plus 3v square. Am I right now? Right. So now actually this can be put in variable separable form. 2v into v square, you keep to it here itself only, no problem. So now v into v square minus 1 by 1 plus 3v square, transpose this side. So then we can write this one as, see, very interesting, 1 plus 3v square divided by v into v square minus 1. This v square minus 1 we can write a square minus b square form, a minus b into a plus b. This we can write v minus 1 into v plus 1 dv. This dv is equal to, already here we have negative 2, x by dx becomes negative 2 dx by x. Integrating on both sides, integrating on both sides, integrating on both sides. So integrating on both sides, what do we get? So my dear students, what do we get? Let us see. So integrating on both sides, what do we get? See, integrating on both sides means this is integral 1 plus 3v square v into v minus 1 times v plus 1 dv minus 2 common, integral of dx by x. Here my dear students, left hand side. So if you observe left hand side, 1 plus 3v square by v into v minus 1 v plus 1. Here 1 plus 3v square degree is 2, whereas v into v minus 1 v plus 1 degree is 3. So that means it's a proper fraction. And also we have the fact here, actually linear factors. How many linear factors we have here? 3. One is v minus 1, v plus 1. So we need to add, first of all we need to find out partial fractions of 1 plus 3v square by v into v minus 1 v plus 1. Then after that it can be integrated in easy manner. So that means, say this is actually something equation 1 now. Right. First let us find out partial fractions. Partial fractions means, let us consider, let 1 plus 3v square by v times v minus 1 and v plus 1. So this is in the form of, actually here see, here for each linear factor you get a one partial fraction of the form corresponding to that one. For v, a upon v plus v minus 1 b upon v minus 1 plus c upon v plus 1. So now take the LCM. What is the LCM? V into v minus 1 and v plus 1. So v into v minus 1 v plus 1 divided by v gets cancelled. We have a times v minus 1 into v plus 1 plus v into v minus 1 v plus 1 divided by v minus 1. V minus 1 cancel, b times v into, wait 1 minute. So this is v into v plus 1, next plus v plus 1 cancel, cv into v minus 1. So comparing on both sides, what do we get now here? So a times v, a into v minus 1 v plus 1 plus b into v plus 1 plus c into v minus 1 is equal to this one, 1 plus 3v square. Because what happens means, this one gets cancelled indirectly. So now we need to find out the actually undetermined coefficients. We call capital A, capital B, capital C is called actually coefficients. Those coefficients we need to determine now the values. By simple substitution we will get it now. First put so v is equal to 0. So see what do we get now? V is equal to 0 means v into v plus 1, 0 into something 0, v into v minus 0 into something 0. That means we are going to find out a value. So a into, in the place of v 0 write down 0 minus 1 minus 1, 0 plus 1 plus 1 is equal to 1 plus 3 into 0. So obviously this will be 1. So this is negative a is equal to 1. So a is equal to negative 1. That means a value has been determined. So now to get actually b value now, to get b value. So to get b value, substitute v is equal to 1 now, v is equal to 1. Let us substitute. So let us substitute, put v is equal to 1. If we put v is equal to 1, what do we get? Wherever v minus 1, the v minus 1 factor becomes 0, because 1 minus 1 is 0. So 0 into v plus 1, 0 a, the c into 0, 0, only you are going to get the b value. In the place of v 1, b into 1, 1 plus 1 is 2, equal to 1 plus 3 into v square, 1 square is 1 only. So 1 plus 3, that will be 4. So 2b is equal to 4. So b is equal to 4 upon 2, that will be 2. So therefore b is equal to 2. So now the b value has been obtained here. So we need c value. How to find out c value now? You might have expected here. Very simple. Put v is equal to negative 1. If we put v is equal to negative 1, v plus 1 becomes 0. So v plus 1, a becomes 0, b becomes 0. We are going to get c value. C into, in the place of v, negative 1. So negative 1, negative 2 is equal to 1 plus 3v square. 3 into negative 1 square, 1 only. So this is negative into negative positive. 2c is equal to 4. Obviously c is equal to 4 by 2, 2. C is equal to 2. Now we can find out the partial fractions of this one. Partial fractions of this one. So now 1 plus 3v square by 1 plus 3v square by v into v minus 1, v plus 1, you can write it now. So that means actually here you can write therefore 1 plus 3v square by v into v minus 1, v plus 1 can be written as a by v. A means how much? Negative 1. So negative 1 by v, b value is 2, plus 2 by v minus 1, plus c is 2, 2 by v plus 1. These are the partial fractions. So now we need to substitute here. So by substituting, you will get it now. Right, let us try to figure it out, right. So now we can write like this. From equation 1, so integral of negative 1 by v plus 2 by v minus 1 plus 2 by v plus 1 dv is equal to, once again check it, negative 2, this is negative 2 integral dx by x. See, now we can integrate first function, second function, third function. So this is minus integral of 1 by v and dv, variable of integration, plus 2 into integral of 1 by v minus 1 dv plus 2 times integral of 1 upon v plus 1 dv, or 1 divided by dv, is equal to minus 2 times integral of dx by x. Clear? Right. So now, my dear students, very interesting here, you remember, integral of 1 by is log v. So minus integral of 1 by v is minus log mod v, plus integral of 1 by v minus 1 also log mod v minus 1, but constant 2 is there, 2 times log mod v minus 1 plus 2 times log mod v plus 1. right, is equal to minus 2 times log mod x plus log mod c. Let us simplify. So this we can write now. Right. So this take 2 common. If you take 2 common here, 2 into log of mod v minus 1 log mod of v plus 1, log a plus log b log ab, these two we can multiply. So this minus log mod v plus 2 times log of mod, very interesting, v minus 1 into v plus 1, v square minus 1 mod, equal to this we can write. So this we can write now log x to the power of x square minus log x square, minus log x, it becomes power, so log mod c, right. So this we can write now log mod v square minus 1 whole square minus log mod v equal to minus log x square plus log mod c, right. This is log a minus log b, log a by b you can write. So this we can write now log of mod v square minus 1 whole square by v is equal to, this is log mod of c by x square you can write. By comparing we get now v square minus 1 whole square by v equal to c upon x square. By cross multiplication, x square into v square minus 1 whole square is equal to cv, you can write it. But what is v? That we need to substitute. So what is v? You can check it. V, see, v is equal to y by x. V equals to y by x, right. So let us substitute here, v is equal to y by x. Right. So now let us move to the next page. X square into v square, in the place of v substitute y by x. So then you get like this also. Here let us do here now. Let us simplify here itself only. See. So now we can write x square into y square upon x square minus 1 whole square equal to c y by x. So this we need to simplify. X square into y square minus x square by x square whole square is equal to cy by x, right. So otherwise let us make simplify separate form. This one. So let me write once again very clear manner this one. So we have x square into y square minus x square whole square, y square minus x square by x square whole square equal to cy by x. So this rub it out, right, this one. So now this we can write it now, x square into y square minus x square whole square or x square minus y square whole square, both are same. So x square minus y square whole square upon this we can write x square whole square means x to the power of 4 cy upon x. So x to the power x square by x to the power of 4 means here x square you will be getting x square and x1 ja x times and cross multiply. What do we get? X square minus y square whole square is equal to cy into x cxy. So this is the required general solution. So very interesting problem. See the previous one. This is C. So you should be familiar with the partial fractions also in order to solve this problem. So you can check step by step also once again. I will explain the same problem tomorrow also. Just go through once again. Just glance for a while. Right. This is a given one. Right. Here see, this is very important. This step is very important. Partial fractions. Up to this one is partial fractions only. Next after that integration, right? So simplification. We have x square into 1 minus y square minus x square by x square whole square cy by x. So go to next page. What happens now? This is x square into y square minus x square whole square, y square minus x square by x square whole square. So this we can write x square into x square minus y square whole square by x square whole square x to the power of 4. So x square x to the power of 4 means we get x square here, and x gets cancelled. Here we have x. By cross multiplication, x square minus y square whole square is equal to cxy. This is the general solution of the given differential equation. Okay, tomorrow we shall discuss remaining problems. Till then, goodbye. See you. Have a nice day. Right. It may be written even like the c into x square minus y square whole square is also xy also you can write it, no problem. But same solution we can write. If you bring c this side, 1 by c is also mere constant. C times x square minus y square whole square is equal to xy. Some textbooks answer may be like this also, no problem. Anyway you can write it. Right. So we shall meet you in the next session. Thank you. Bye bye. Once again watch the previous videos also. We have started a differential equation series from basic concepts onwards we have discussed so far. This is the actually 11th part. Already 10 parts have been discussed. You can watch the previous videos also. Then easily everybody can learn. So that means without actually referring any textbook also, by your own you can learn engineering mathematics irrespective of this differential equations. It will be useful for ESET examination, even sometimes GATE examination, even for a DSC school assistant examination. Any type of entrance examination can be dealt very easy manner. So by solving all these problems. Okay, bye. See you in the next class.